Today we'll be solving the LeetCode problem of the day, fraction to recurring decimal. In this question, you're given two integers, numerator and denominator of a fraction, and you just have to return the fraction value in a string. So let's take an example. We have numerator 1 and the denominator 2. So for this, the fraction value will be 0.5. So we just have to return this as a string. Second input is 2 by 1. So the value will be just 2. So we just have to return 2. Now for the third input, we have 4 numerator and denominator 333. So if we divide it, we get the value as this. So for this, the value will be 0.012, 0.12 and so on. So it just keeps repeating. So when it just keeps repeating, we can't just return a string of infinite size. So whatever part is repeating, we just have to enclose it in a bracket. So for this, the answer will be 0. In brackets 0, 1, 2. So this denotes that the 0, 1, 2 is repeating. Like how we have 4 by 3. So for 4 by 3, it is 1.33333. So we will just return 1 point in brackets 3. Also, for the numerator and denominator, it is from the range negative 2 power minus 2 power 31 and positive 2 power 31 minus 1. So basically the entire integer range. So the numbers can be negative as well. So in that case, if we have minus 1 as a numerator and denominator 2, then the result will be minus 0.5. And similarly will be the case when the denominator is 2. And suppose if both numerator and denominator is negative, then we will just, when we divide negative with negative, it becomes positive. So we just return 0.5. Now coming to the approach, let's understand it using an example. Let's say numerator equal to 25 and we have denominator equal to 4. So we'll just simulate how the division happens. 25 by 4. So 25 by 4 will give you 6 and the remainder will be 1. Now since remainder is not equal to 0, we proceed further. So we just put a dot and we multiply by 10 and we proceed. So 4 times 2 is 8 and the remainder is 2 and we multiply by 20 to proceed further. So 4 times 5 is 20 and now the remainder is 0. Now we have the remainder as 0, so we stop. So whatever answer it is formed so far, we just return it. So for numerator 25 and denominator 4, the fraction will be 6.25. Now this is the case where we don't have the decimals repeating. Now let's see for this case where we have repeating in the fractions. So here the numerator is 4 and the denominator is 333. So 4 by 333 will give you 0 and 0. The remainder will be 4 only. So to proceed further, we'll just put a 40 and we'll just put a dot. Now again, this multiplied by 0 will give you again 0 and remainder will be 40. But before proceeding, let's keep a note where the answer of 40 is starting. So for the 40, let's just simulate it first. So 333 times 0. So for the answer for the 40 is starting at this point. Okay, so 3 times 0 is this 0 and the remainder is again 40. So we again multiply by 10 and proceed. So 333 times 1 is this and now we have the remainder as 67. Now to proceed further, we multiply by 10, and 333 times 2 will give us 666. Now we see the remainder is 4, and then we multiply by 40. Now we see that the 40 is repeating again. So when we had 40, our answer was starting to build at this point, and so far it is 0, 1, 2. Now for 40, if we repeat the same thing, we would again get the values as 0, 1, 2, and after that we will again reach a 40. So for the 40, again we will get the answer as 0, 1, 2, and so on. So what if when we encountered 40 for the first time, we will store somewhere where the 40 is starting. So now we have 40. So we see that 40 is already present, and let's say for 40, the answer, the new answer is starting to form from index 2. So this is index 0, this is index 1, this is index 2. So we see that for 40, the answer is starting to form from index 2. So when we have a 40 repeating again, we can safely say that whatever my answer is so far, from where it is starting and from where the answer is currently, that part is repeating. So when we have the 40 repeating, we'll go and insert opening bracket at this index 2, and we will put a closing bracket at the last, and we'll just return whatever this is so far. So for numerator 4, denominator 333, the answer will be 0 point in brackets 0, 1, 2. So let me just simulate how for each step we will note where the point is starting. So for that, let's start the division again. Let me just erase all this. Yeah. So initially we just divide it by 0 and we get 0. We get the remainder as 4. And we put a dot and it starts with 40. So for 40, we create a hash map. So the key will be 40 and the value will be the index where it is starting. So index 0 is this, index 1 is this, index 2 is this. So we can say for 40, it is starting at index 2. So the value will be the string size so far. So currently it's 2. And we proceed. So this will be 0, 0, 40. Remainder remains 40. Now we just multiply. Now for 400, we create a key 400. And for 400, it is starting at this point. So the starting point will be 3. And let's proceed. So 333 times 1 is this, and the remainder is 67. And then we just multiply by 10 as well. Now again for 670, it is starting to form from here. So we'll store this as well. For 670, it is starting to form from index 4. So this times 2 is 666. And the remainder is 4, and then we multiply by 10. Now we see the 40 is already present here, so that means all we have to do is go to the index 2, put a starting bracket, and at the end of the string we just put the ending bracket, and we just return this. Now let's go with the code. So first we'll create a string builder to build our answer, and at the end we'll just convert it back to a string and return. New string builder. So first step is we need to verify whether our division will result in a negative value or not. So for that, so the first case is if the numerator is positive and the denominator is negative. So for this case, the final answer will be negative. Or we can also have a case where the numerator is negative and the denominator is positive. So for both of these cases, the final answer is negative. So at the starting itself, we will append a negative sign. Also, after doing this, we have to convert numerator and denominator both to positive. So for that, we can just use math.absolute value. Also, let me just take a long variable to store these values, because when we multiply and all, the value can overflow the integer range. So this is for the numerator, converted to positive if it's a negative, and this is the denominator, converted to positive if it was negative. So first let's get the integer value of the answer, sp.append numerator by denominator. And once we do that, we take remainder with denominator, and if the remainder equal to 0, that means the division is perfect, so we don't have any decimals, so we can directly return sp.toString. Now once this if condition is false, that means we have a decimal places. So first step is we put a dot. After the integer part, we just put a dot, and then we proceed with a division until the remainder becomes 0. So we'll have while numerator is not equal to 0. So first, let's also use an example side by side. The same example for we have numerator equal to 4, and we have denominator equal to 333. Now here what we did is we have got the integer part, so the answer currently contains 0, and we have also appended a decimal, and we did numerator mod equal to denominator, so numerator remains 4. Now inside the loop, first we multiply the numerator with 10, and then we perform the operation. So again we will get the division part, sp.append numerator by denominator, and after that same thing, we will take the remainder. So now we'll check if the remainder, we have already encountered the remainder before. So for that we can use a hash map key is long, value is integer, hash map. So if map dot contains key numerator, if it's already present, all we have to do is in the string we will go to that position, insert map dot get numerator. In that position we will insert an opening bracket, and at the end sp.append we will append a closing bracket, and since this is done, we'll just do break, and at the end we will return sp.toString. Now if the numerator is repeating, if the remainder is repeating, if it's not repeating, all we have to do is we should insert it in the map.put numerator, and the position will be sp.length, and just we return the string at the end after converting it to string from string builder. Yeah, test case are passing. Let me just submit. Yeah, it works. Now let's do the time and space complexity analysis. So coming to the time complexity, we have this while loop, and this loop runs while the remainder is not equal to 0 or any remainder is repeating. So when we do numerator by denominator, so we are doing the mod with this denominator. So all the reminders it can take are from 0 to d minus 1. So this loop will run at most d minus 1 times, because after that any remainder should be already found and it is already repeating. So when a remainder is repeating, we just break. So the time complexity will be order of the denominator, and the space complexity will also be order of denominator. But we can see that order of denominator will be up to 2 power 31, which is up to 10 power 9. But in the question, it is guaranteed that the length of the answer string is always less than 10 power 4. So that means those kind of inputs won't be given. So at max, the time complexity will be bounded by 10 power 4. So it will pass. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.